Welcome to Lesson 4 of the USB Network Gate SDK tutorial. In the last video, we installed the SDK and set up a server application that can retrieve a list of devices physically plugged into that computer. In this lesson, we'll create the client project to access those devices over a network. Just like in Lesson 2, we'll start by setting up a new WPF project and importing the USB Network Gate SDK, making sure that the DLL and corresponding C# files are copied into the project. If you don't already have the SDK installed, then check out Lesson 2 to see how to install it and import the necessary files. Just like the server in the previous lessons, the demo client project is available for download online. So even though this video doesn't cover every single line of code, it's available at the link in the video description. This project will follow the same simplified model view architecture as the server. In the model.cs file, we'll need to add a class called USB device, but this is not identical to the one in the server. For example, it doesn't need to store a pointer to a USB device context. Instead, it stores a device index property and a bunch of display information, as well as the connection properties and some commands that we'll use to control the actual process of connecting to the device on the server. The model has an abstract class called Client Context Wrapper, which inherits from that same observable object we talked about in the server project. This essentially wraps the USB Network Gate context object, storing an integer pointer to it. However, the method to actually create the context is abstract, so that subclasses can implement it in their own way. This will become important in the next lesson. We'll add one more abstract method signature called processDevice that will be used by subclasses when retrieving device lists, and then come back to this class in just a bit. The next step is another abstract class called Group, which inherits from Client Context Wrapper. Group will store an observable collection of USB devices, as well as a name property. We'll fill out more functionality for this class in a bit. For now, we can finish off the inheritance tree with a concrete class called AddedDevicesGroup, which inherits from Group and defines its own method for creating the UNG context by simply making a call to client_enum_avail_remote_dev to initialize the context pointer. Next lesson, we'll add another type of group that can connect to devices using the remote desktop protocol. The model class itself stores a list of group types that can be displayed in the user interface, and it needs to have two command objects. The first is called findCommand and is triggered when the user attempts to find a device to connect to, and the second will be called addManually_command, which fires when the user wants to manually enter properties for a connection. Now let's move on to the view. Like the previous project, we won't cover everything in the user interface in this video because it's not all necessary for understanding how to work with the SDK. However, you can of course find the whole user interface in the sample project linked in the description. For now, it's sufficient to say that in the mainWindow.xaml file, we'll need a tree view that binds to the groups property in the model object. Then each child of the tree view will bind to the devices property of each group, creating a hierarchical data structure very similar to the one we made for the server. Then we'll place two buttons at the top of the interface that correspond with the two commands in the model. One button will say Add Shared Device and bind to the find command, and the other will say Add Shared Device Manually and bind to the Add Manually command. Now that we've set up the basics of the model and view, let's make them actually functional. We need to be able to retrieve the list of devices from the server, and we'll implement this inside the Client Context Wrapper class. First, we'll add two non-abstract functions to Client Context Wrapper called DestroyContext and Reload. The first one does exactly what you'd expect it to do, using the SDK function client_remove_enum_of_remote_dev to remove the current UNG pointer from memory and reset it to 0. The reload function then can call DestroyContext and make a new context pointer. Since createContext is an abstract function, it will need to be overridden by any subclasses, but we'll get to that in a second. Then we'll define and call a third function, enumerateDevices. And this method is where all the magic happens. We'll use a for loop to get all available devices from the context and initialize them. Calling clientGetRemoteDevName checks whether or not there's a valid device name at this index, and calling clientGetRemoteDevNetSettings checks whether or not there's a device set up at this index. If either of these returns false, then we break the loop because there are no more devices to retrieve. However, if they both return true, then we call the abstract processDevice method on the device. The subclasses that inherit from clientContextWrapper will have their own ways of processing each device and applying settings to it, so that's why we leave this as an abstract method. The next step is to override the processDevice function in the group class. It'll take a device index name and then a string containing the connection settings. It's important to note again that we're not referring to devices with their pointers in memory, but rather with an index number that's been assigned to them. We'll first check if there's a port contained in the connection string, and if so, assign a human-readable value to this settings string. Then, calling clientGetStateRemoteDev gives you the current state of the device and the server connection information in this remote host object field. If no name was retrieved from that call to the SDK, we can just fill out the name with the default unknown device string. Then all this retrieved information is used to create a new USB device object and add it to the group's list of devices. We'll assign functions to these action commands to connect, disconnect, and delete a device. They will all go within the group class and take a USB device as the argument. To actually connect to a USB device, however, we need to go and fill out those functions that were assigned to the device commands. Disconnect and delete are incredibly simple. To disconnect a device, call clientStopRemoteDev, and to remove the device from the context, call clientRemoveRemoteDev. Then, after either of those operations, we'll call reload to refresh the list. Actually opening a device connection takes a few more lines of code, but it's still very easy. We just need to call the SDK function, clientStartRemoteDev, passing in the UNG context, the device index, a Boolean indicating whether or not to auto-reconnect by default, and then the password. If no password is necessary, you can just use null or an empty string as this final argument. After that, call reload to refresh the device list so the devices in the user interface are all up to date and everything's good to go. Now that this functionality has been added to the group class, all we need to do is add an added devices group to the group's property of the model, and the program will be able to retrieve the list of devices available over TCP/IP for a given server. To put it all together, we can go back to the server application we built earlier and start it. Then I'll also start the client project and put them side by side on screen here. I've got a flash drive plugged in, and I'll make it available for sharing from the server app. Then on the client, I'll enter the server information, which is just the localhost IP since both programs are running on the same computer, and list all devices. Then I can connect to it using the code that was just added. Even though both programs are running on the same computer, the device is still being shared over the TCP/IP protocol. Now that we've connected devices between the server and the client, the program is really starting to shape up. There are a few more options for advanced configuration and customization that we'll discuss in the next lessons, and then in the sixth and final lesson, we'll go over everything you need to know in order to correctly activate a license and deploy an entire application stack that uses USB Network Gate.